So we're gonna look at chemical equations. The goal is to first of all know what the component of chemical equation is. We want to learn how we read chemical equations, and we're going to learn how to balance chemical equations. And alternatively, we're going to show you how to complete a chemical reactions. We're going to show you how to predict the products of a chemical reaction and balance it. Now, let's look at a format of chemical equations. We learned before that the yield tells us which direction your reaction is going. So the arrow is always pointing towards the products. So this reaction, just by looking at the arrow, we know that aluminum metal and oxygen gas are the reactants, and aluminum oxide is a product. So we learned that the coefficients that come right before chemical formula are used to balance a chemical reaction, and the reason we use them is for the law of conservation of mass. So if we start with 4 aluminum atoms, we should end up with 4 aluminum atoms too. So during the chemical reaction, a process, no atom mass is created nor destroyed. So aluminum may change into another compound. For example, here aluminum metal is transforming into aluminum oxide, which is an ionic compound. That's totally okay. That's why we do chemical reaction. This is a chemical change. However, if you start with 4 aluminum atoms, you should end up with 4 aluminum atoms too. Same thing with oxygen. In the reactant side, you have 6 oxygen atoms. So on the product side, you want 6 oxygen atoms too. So this balancing coefficient is what's going to be the focus of this lecture. We're going to learn how we come up that coefficient for 4, coefficient for 3, for coefficient of 4 for aluminum, 3 for oxygen, and 2 for aluminum oxide. One thing to keep in mind is that these balancing coefficients have to be whole number, and they have to be the smallest whole number. So we can't have fractions. Now also remember that if there are special conditions for the reaction, such as pressure, temperature, we can write those on the arrow. So for example, here that triangle in chemical equation that represents heat. For example, here this heat means that the triangle here means that heat is supplied to the reaction. Also, the physical states of each substance is also indicated for each one of these. So the physical state for some of the chemicals, materials, substances is going to be easy. So for example, all the metals, you expect them to be solid except for mercury. So if you do a chemical equation, you come across a metal in your equation, just remember that all the metals are solid except for mercury. So you're expected to know this. Diatomic gases, hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, iodine. We know that those are gases. Ionic compound, keep in mind that ionic compound, which are salts, they are solid because of the strong interaction between cations and anions. So as long as there is no water in our reaction, they appear as solid. And as you see here, aluminum is a metal, that's why it's a solid. Oxygen is one of the diatomic gases, so gas. And aluminum oxide is an ionic compound because aluminum is a metal, oxygen is a non-metal, there is no water, so aluminum oxide is a solid too. So these are the general rules. So once we do chemical equations, I show you other ways you can tell what the physical state of each substance in a chemical equation is going to be. So this table just summarizes everything we talked about, different symbols in a chemical equation. So plus is used when you have more than one reactant and one product. The arrow shows, or the yield, that always points towards the products. That would allow us to know which direction a reaction is going. So S stands for solid, L for liquid, G is for gas, AQ stands for aqueous solution, meaning substances that are dissolved in water. So if you have, for example, sodium chloride, table salt, you dissolve it in water, that becomes sodium chloride aqueous solution. So this AQ comes from aqua. And then the heat the triangle represents the heat in chemical equations. So let's look at a couple of examples. So in the reaction given here, copper 2 sulfate and barium bromide, which produces copper 2 bromide and barium sulfate. Which are the reactants and which are the products? So you look at the arrow, the yield, it's pointing towards the copper 2 bromide and barium sulfate. So those two are the products, and copper 2 sulfate and barium bromide are the reactants. So the answer is B. Now let's see how we can write chemical equations. So for chemical equations, we're gonna use the symbol or a chemical formula for any substance. We don't wanna use words. So the goal is to use the chemical formulas. So it's important that you know how to write chemical formulas and you know how to go from a name of a compound to the chemical formula. So make sure that you know how to write chemical formula and make sure that you know the naming, the nomenclature for different types of compound. So let's look at an example here. Hydrogen gas and oxygen gas, they produce water gas. So hydrogen and oxygen are diatomic molecules. So to write the formula for them, that's H2 and O2, because hydrogen and oxygen are one of the diatomic gases and they are in a gaseous form. And water, since it says in a gaseous form, you have H2O gas. Now this is writing the chemical equation. After you write the chemical equation, you always have to make sure that the reaction is balanced. So before moving on, you always want to balance the chemical equation. So to balance, you start with hydrogen or oxygen, doesn't really matter. So you have 2 hydrogens on the product side, you also have 2 hydrogen. Now looking at the oxygen on the reactant side, you have 2 oxygen. However, in water you only have 1 oxygen. So you're gonna have to balance the number of oxygens. So to balance the number of oxygens, you use the coefficient in front of water. And since you use a coefficient for water, that changes the number of hydrogen atoms. So you have to go back and change the coefficient for H2. So again, remember that when you're balancing, you're just changing the coefficients. The coefficients are called balancing coefficients. Coefficient is the number that comes before a chemical formula. Don't change the subscripts. Subscripts we use to write the chemical formula. So you just balance the number of atoms on both sides of the equation by using balancing coefficients. One other point here, that if your balancing coefficient is 1, you don't write it. But also keep in mind that if we don't write it, it doesn't mean that it doesn't exist. It's there. We just don't write the number 1 for our balancing coefficients. Same as subscripts. When you use subscript 1, we didn't write the number 1. Now, so that's the whole idea of balancing. We want to make sure that on both sides of the equation, the number of atoms are the same. So I'm going to show you different examples of different equations and how we can balance different types of chemical equations. So let's look at this one. So you want to write the reaction chemical equation for this process where phosphorus burns in air to produce diphosphorus pentoxide. So phosphorus burns in air, meaning that it reacts with oxygen. And what it produces, meaning your product, is diphosphorus pentoxide. So
there have to be like at least 4 atoms.
Very good. Yeah, so phosphorus appears as a P4. So we had diatomic molecule that were at the exceptions, always diatomic. Phosphorus and sulfur were exceptions too. So phosphorus is always a P4 in an elemental form, and sulfur was S8 as an elemental form. So P4, because you have phosphorus, plus oxygen, so solid gas, gives you diphosphorus pentoxide. What's the formula of diphosphorus pentoxide? Very good. It's a molecular compound, P2O5. So first step is writing the chemical equation, identifying what the reactants and products are, writing the chemical equation. And now after we write the chemical equation, we want to balance it. Remember, for the law of conservation of mass, the number of atoms on each side has to be the same. Since we don't know exactly how much of each substance we're using, we look at the number of atoms. Now, the general rule for balancing chemical equations, or what helps us to do it easier oftentimes, is doing it this way. So when you balance, first try to balance all the metals. Then focus on all the nonmetals you see in your chemical equations. And then at the end, you want to do hydrogen and oxygen. So if you follow this order, it will help you balance the chemical equations easier. So this is how you want to do it. You look at your equation. Do I see any metals? We don't, right? But we see a nonmetal, phosphorus. So we have only phosphorus and oxygen. So I'm going to balance phosphorus first and then the oxygen. So you have 4 phosphorus on the reactant side. In order to have 4 phosphorus on the product side, you need a coefficient of 2. And now you have 10 oxygen on the product side. So you would need 5 oxygens here to balance this reaction. So you have 4 phosphorus here and 4 phosphorus here. 10 oxygen on the reactant side and 10 oxygen on the product side too. So this reaction is balanced. So let's do another example. For now, we're gonna put our focus on just balancing. We're not gonna focus too much on the physical states. I'll show you how to do the physical states too. But for now, let's just focus on balancing. So given this unbalanced equation, that's a reaction of hydrochloric acid and ammonia that gives you ammonium chloride. You want to know, after it's properly balanced, what's the sum of the balancing coefficients. So it means that you first want to balance the equation, and then you add up the balancing coefficients to see what the sum of the balancing coefficients is. So there is no metal here, so the only non-metals are nitrogen and chlorine. And it doesn't really matter which one you balance first. So I usually start with the first compound so I don't miss or forget any of the atoms. So 1 chlorine in the reactant side, and you see 1 chlorine on the in the product side. 1 nitrogen in the reactant, 1 nitrogen in the product. So they're already balanced. Now, in terms of hydrogen, you get 1 hydrogen from hydrochloric acid. So 1 hydrogen here, and 3 hydrogens from ammonia. That's a total of 4 hydrogen for the reactants, and you have 4 hydrogen on the product side too. So the reaction is balanced. The coefficients are only 1. Now, to see the sum of balancing coefficients, although you don't see any coefficient, but remember that these are still 1. We just don't write 1. So the sum of the balancing coefficients is 3. Let's do another example. You're looking at a reaction of ammonia where it decomposes and it gives you hydrogen and nitrogen gas. So you want to balance this equation, and after you balance it, you want to know what the sum of the balancing coefficient is. So to balance the equation, we're first going to balance nonmetals except hydrogen and oxygen. So the only nonmetal you have here, except for hydrogen and oxygen, is nitrogen. So 1 nitrogen in the reactant side, however, you have 2 nitrogen on the product side. So to balance the number of hydrogens, you're gonna use coefficient. So 2 ammonia. And now you're gonna have to balance hydrogen. On the reactant side, you have 6 hydrogens, and you would need the coefficient of 3 to balance the number of hydrogens. And after you're done, you always double check. 2 nitrogen on the reactant, 2 nitrogen on the product. 6 hydrogen and 6 hydrogen, so the reaction is balanced. Now the sum of the balancing coefficients is 6. So the answer is B. All right, let's look at another example. You want to write the reaction in between zinc metal and silver nitrate, which produces zinc nitrate and silver metal. So first we got to write the reaction and then balance it. So zinc plus silver nitrate gives zinc nitrate and silver. To balance, remember, we first want to balance all the metals, then all the nonmetals, then hydrogen and oxygen. So you have 2 metals here, zinc and silver, and it doesn't matter which one you start off with. So 1 zinc, and then 1 zinc on the product side, 1 silver, 1 silver. Now, here, if you pay attention, although you have nonmetals of nitrogen and oxygen, however, NO3, the nitrate ion or nitrate, it's one of the polyatomic ions, it appears on both sides of the equation. So in the reactants, you have silver nitrate. In the products, you have zinc nitrate. So if you see polyatomic ions, and if they appear the same on both sides of the equation, meaning that they don't break, balance the polyatomic ions as 1 unit. So you want to balance polyatomic ions as 1 unit. So what does that mean? So in the reactant side, in silver nitrate, I see 1 nitrate. Now on the product side, from zinc nitrate, you see 2 nitrates. So to balance the number of nitrates units, I give a coefficient of 2 to silver nitrate. Now as soon as you do this, the number of silver atoms change. So I gotta balance the number of silver on the other side of the equation. And you always want to double check. So 1 zinc, 1 zinc, 2 silver, 2 silver, 2 nitrate, and 2 nitrate. So this equation is balanced. Let's look at another example. You're looking at a reaction of cobalt and copper 2 sulfate that produces cobalt 3 sulfate and copper metal. You want to balance this equation, and after you balance, you want to know the sum of the balancing coefficients. So to balance this, again, remember you first want to balance metals, then non-metals, and if you see polyatomic ions, you want to balance them as a unit. Now, 1 cobalt on the reactant side, and you have 2 cobalts on the product side. So to balance the number of cobalts, you want to use the coefficient of 2 here. Now 1 copper in the reactant, 1 copper in the product, so that's balanced. Now for sulfate ion, you see 1 sulfate in the reactant and 3 sulfate on the product. So to balance the number of sulfates, you need the coefficient of 3. And as soon as you put that 3 in front of copper 2 sulfate, the number of copper atoms change. So you gotta put the coefficient of 3 for copper as well. Now the sum of the balancing coefficients is going to be 9. Another example. Now you're looking at a reaction of aluminum hydroxide and sulfuric acid that produces aluminum sulfate and water. So the goal is to balance the equation, and once you balance it, you want to know what the sum of balancing coefficients are. So to balance this, we first want to look at our metal, which is aluminum. So 1 aluminum on the reactant side, you have 2 on the product side, so you're going to need to have a coefficient of 2 here to balance the number of aluminum atoms. Now you look at the polyatomic ions as a unit. 1 sulfate on the reactant side, you have 3 on the product side, so you're going to need to have 3 sulfuric acid. Now the only thing that's left is oxygen and hydrogen. So let's do the hydrogens first. So 2 times 3, you have 6 hydrogen from aluminum hydroxide, and then 6 hydrogen from sulfuric acid. That's a total of 12 hydrogens. So you're gonna need to have 6 water here. And then to look at the oxygens, you have 6 oxygen in aluminum hydroxide, 12 oxygen from sulfuric acid, which is a total of 18. Now you have 12 oxygen from aluminum sulfate and 6 oxygen from water. So just to double check, you have 2 aluminum on the reactant side and you have 2 aluminum in the product side. You have 18 oxygen on the reactant side and 18 oxygen on the product side. 12 hydrogen on the reactant side, 12 hydrogen on the product side, and then you have 3 sulfate and 3 sulfate on both sides too. Now let's move on to different types of chemical equation which are called combustion reactions. So you're looking at a reaction of ethylene. When it burns in air, it produces carbon dioxide and water. So the formula for ethylene is C2H4, burning in air, meaning that it reacts with oxygen and it produces carbon dioxide and water. So any reaction where a hydrocarbon, meaning substances that are composed of carbon and hydrogen, they react with oxygen, which is burning, and then they produce only carbon dioxide and water. These are called combustion reactions. So this is called a combustion reaction. So the product of a combustion reaction is always carbon dioxide and water. And we call this combustion reaction because from the burning reacting with oxygen, lots and lots of energy in the form of a heat is released. Now, for combustion reactions, where you need to know that the products of a combustion reaction is always carbon dioxide and water. So to balance combustion reactions, you first want to balance carbon. Then you want to balance hydrogen, and at the end, you want to balance oxygen. So this is the order you're going to use in order to balance combustion reaction. First, balance carbon, then hydrogen, and then at the end, you want to balance oxygen atoms. So let's balance this equation. So you have 2 carbon from the reactant side, so you're going to need to have 2 carbon. On the product side 2. Now to balance hydrogens, you have 4 hydrogen on the reactant, so we need 2 water molecules to balance the number of hydrogens. Now to balance the oxygens, you're going to have to look at the product side because all the substances in your product side are already balanced. So you have 4 oxygen from carbon dioxide and 2 oxygen from water, which is a total of 6 oxygens. So to balance that, you're going to need to have 3 oxygen gas. So let's look at another one. Acetylene burns in air to produce carbon dioxide and water. So this is another combustion reaction. So acetylene is C2H2, burns in air, meaning that it reacts with oxygen to produce carbon dioxide and water. So to balance, we first are going to balance carbon, then hydrogen and oxygen at the end. So 2 carbons for acetylene, meaning that you're going to have 2 carbon dioxide. 2 hydrogen for acetylene, and we already have 2 hydrogen from water. Now we got to balance the number of oxygens. So you get 4 oxygen from carbon dioxide, 1 oxygen from water, which is a total of 5 oxygens. But how do I do 5 oxygens for O2? So there are different methods that you can balance this. What I'm going to show you is one of the methods here. So in order to end up with 5O2, I'm going to give the coefficient of 5½ to oxygen here. Why 5½ Because then the 2's cancel out and you end up with just 5 oxygen. But remember that we can have coefficients as our balancing coefficients. It has to be a whole number. We can't have fractions. That's what I meant, fractions. So in order to not have a fraction, I'm going to multiply the entire equation by 2 to eliminate the half, that 5½ coefficient that I have. Now, when you multiply by a factor, every single reactant and product needs to be multiplied by that factor. So that gives me 2C2H2, 5O2, 4 carbon dioxide, and 2H2O. Now the equation is balanced. So let's do another combustion reaction. So this is a reaction of ethane, C2H6, and oxygen that gives you carbon dioxide and water. So to answer these questions, you will need to balance the equation first, and then you want to look at the sum of the balancing coefficients. So to balance, we first want to balance the carbons. So 2 carbons for C2H6, you're going to need 2 for carbon dioxide. Now for hydrogen, you have 6 hydrogen from C2H6, so we need 3 water. And in terms of oxygen, you get 4 oxygen from carbon dioxide, 3 oxygen from water. That's a total of 7. Now, we gotta eliminate the fraction, so I'm going to multiply everything by 2. So that leads to 2C2H6 plus 7O2 gives us 4CO2 and 6H2O. Now for the sum of balancing coefficients, that's 2 plus 7 plus 4 plus 6, which is 19. Another combustion reaction. So you're looking at a reaction of propane, C3H8, with O2 that leads to the formation of carbon dioxide and water. So first we're going to balance the carbons. So 3 carbons from propane, so you would need 3 CO2. To balance the hydrogens, we have 8 hydrogen from C3H8, so you're gonna have to have 4 water. And then for the oxygens, you have 6 oxygen from carbon dioxide, 4 oxygen from water. That's a total of 10 oxygens. So we're gonna need to have 5 oxygen gases on the reactant side. Now, the sum of the balancing coefficient, we have 1 for C3H8, 5 for O2, 3 for carbon dioxide, and 4 for water, which gives us 13.